As I told you that we are just doing our calculus. In calculus we have discussed the domain, we discussed the limit, we discussed continuity, and then we discussed the derivative of the function. So next topic is our integration, how we integrate the function. So as I advised you before, that we need the formula for integration and formulas for differentiation. If you are good in that one, then these problems are very easy for you. I will recommend strongly that you revise this portion of the formulas for the differentiation and integration. Now, when we want to integrate, we have two types of integral. One is the indefinite integral, one is definite integral. Definite integral having the limits. Indefinite integrals are not having the limits. So the formula is that we have the vectorial function r of t is equal to f of t I plus g of t j plus h of t k, where f of t, g of t and h of t are the functions which are integrable. So then we are just going to take the formula that r of t dt is equal to f of t. Each component we take the integral always followed by dt. So integral f of t dt I plus second term will be integral g of t dt j, and then the third one will be h of t dt k. So the next is the definite integral, and this is over the interval a to b. So we say it's a to b r of t dt, and again we are just going to put the limit to each of the integration. So first term will be a to b f of t dt I plus integration of a to b g of t dt j plus integration a to b h of t dt k. Now I take an example, this is my example 3. I want to evaluate this integral, and that is equal to my f of t is t square plus 2, my g of t is sine 2t, and my h of t is our 2t to power t square. Now we are having here the polynomial function, we have the sine cosine function, and we are having the exponential function. So when we want to integrate it, we have the formula for this one. When we take integration of t to power n dn, so our formula is t to power n plus 1 over n plus 1 plus constant. When we want to integrate here sine of ax dx, sorry at, I use this t, that's better because we are taking here t as our component. So here I am having here this as a t. So when you take at dt, so this will be equal to minus cosine at over a, because when we going to take the derivative of cosine is minus sine, and minus become plus, and then then derivative of at is a. So we go opposite in the case of when we are taking. The third one is our exponential formula, and we are having here e to power u du, and this is equal to then here also a constant c, and we are having the plus here the constant plus c, and here we can write here e to power u n plus constant c. So our u in this case will be d square, and our du will be 2t dt. So our integration will be e to power u square. So we use this one, and we write the integral of this one, that's the integral of the formula. So we want to integrate this one, and we just write here term by term. So first is the integration of the first term. We are having here this equal to t square plus 2i, and I write here dt. This is my first term. So dt I component wise, and then I am having here the second term is plus integral sine 2t dt, this is my jth component, and then I am having here the integral 2t e to power t square k dt. So I have in the first one is my polynomial function. I get here d3 by 3 plus 2t plus c1, and this being multiplied by I. Then here we get here as given the formula, my a is equal to 2. So I'll get here minus cosine 2t over 2 plus c2, I'm having here j, and plus as I told you that in this case we can just take here u is equal to t square. What's my du? My du is equal to 2t dt. The integral I have here e t square into 2t dt. I can rewrite this one is equal to e to power u du, and the result is e to power u. So I can write this equal to, my result will be equal to e to power t square plus c3 k. So I rewrite this one, I take my constants out, and we can write this equal to t cube over 3 plus 2t, and we're having here I getting minus cosine 2t over 2 cosine 2t over 2 j plus e t square k plus c1i, c2j, and c3k. So I can rewrite this one, and I can say, I can write here this equal to, I am having here t cube by 3 plus 2t t cube plus 3 plus 2t I minus cosine 2t over 2 j plus e to power t square k plus c. C is my constant. What's my c? My c is c1i plus c2j plus c3k. So that's my integration of the function. I have this integral, so we make it component wise, and then we have just taken our constant together. That is, c is equal to c1i plus c2j and plus c3k. We can write them separately at the end. We don't write for each term. At the end we write there's just our c and say it's c1, c2, c3. My next example I'm going to give you that we are given here the function that our acceleration is given, and I want to write the position vector. So again, first we have just in the last section we have done, we give the position vector and we found the acceleration. So we did it by integration or by differentiation, and here we are having integration. So for example, I was having, as we can note it here, that we are given here the function here, we are given here r of t, we're given r of t, and then we differentiate this one. Differentiating this one, we get here dr by dt, that's my velocity, and then I differentiate again, I get here d2r by dt square, and that's my acceleration. Now here we are given here acceleration a of t, and we integrate this one, integral of this one, we get here dv by dt and dr by dt, because we have d2r by dt square, dr by dt, and that's my velocity. And then I integrate again, and then I'll get here r of t, and that's my position vector. So that's opposite to that one, we can find the position vector, but here we need here the conditions for finding the constant. So this week I give you an example and give you idea for this one.